we now discuss the solution of a problem from the section Complex Analysis. And the problem is on Schwarz-Pick Theorem. And this question has appeared in CSIR National Eligibility Test held on 30th November 2020, and it is from the section C. The problem is, let D be a subset of C, the complex plane be the open unit disk. Consider the family script F of all holomorphic maps F from D to D such that f of 0 is equal to 1 by 2. For f belongs to the family F, the possible values of mod f prime 0 are, the four options are given to us. Option 1, 7 by 8. Option 2, 5 by 6. Option 3, 3 by 4. Option 4, 1. We now discuss the solution of this problem in detail. Before going into the proof, let us recall a famous theorem, Schwarz-Pick Theorem. Let D be the open unit disk in the organ plane C. Let F be a mapping from D to D, which is a holomorphic function. Then, for all z belongs to D, mod of f prime z by 1 minus mod f of z whole square is less than or equal to 1 by 1 minus mod z square. And this theorem is a variant of the famous Schwarz lemma. You find lemma 6.34 entitled Schwarz-Pick lemma in the following book. The title of the book is Foundations of Complex Analysis by S. Ponnuswamy. Let us discuss the solution. We have D, the open unit disk in the organ plane C. We have script F, the family of all holomorphic maps, that is, the family of all analytic functions F from D to D satisfying f of 0 is equal to 1 by 2. Let f be an arbitrarily chosen function from the family. Therefore, f of 0 is equal to 1 by 2 for this f also. Required to find the possible values of mod of f prime 0. Let us now recall Schwarz-Pick theorem. And the Schwarz-Pick theorem is valid for a map f from D to D, which is an analytic function where D is an open disk. And the theorem says mod of f prime z by 1 minus mod f of z square is less than or equal to 1 by 1 minus mod z square, and this is valid for all z belongs to D. And z is equal to 0 being the center of the open disk D, it is also valid for z is equal to 0. Putting z is equal to 0 in the theorem, we get mod of f prime 0 by 1 minus mod of f of 0 square is less than or equal to 1 by 1 minus mod 0 square. This will imply mod of f prime 0 is less than or equal to 1 minus mod f0 square. And this will imply mod of f prime 0 is less than or equal to 1 minus mod of f of 0, f of 0 square. And f of 0 is 1 by 2, 1 by 2 square. That is 1 minus 1 by 4 is equal to 3 by 4. So, mod of f prime 0 is less than or equal to 3 by 4. A possible value of mod of f prime 0 is 3 by 4. Let us look at the options, and this a possible value of mod of f prime 0 is 3 by 4 is appearing against the option 3. Therefore, the option 3 is true. Now, what about 7 by 8, 5 by 6 and 1? You note down all these 3, 7 by 8, 5 by 6, 1, each one of them is greater than 3 by 4. And hence, this is mod of f prime 0 cannot be 7 by 8, 5 by 6, 1. So, note that these values 7 by 8, 5 by 6 and 1 are not possible values for mod of f prime 0, since each one of them is greater than 3 by 4. So, the options 1, 2 and 4 are not true, and hence our answer is option 3. So, that is the discussion of the solution of the given problem, and it is based on, in fact, Schwarz lemma only, but this is we have used a variant of the Schwarz lemma called Schwarz-Pick Theorem, and the section on Schwarz lemma and its corollaries and applications are very important, and we have been getting problems on Schwarz lemma and its corollaries many times. So, concentrate on Schwarz lemma and its corollaries and applications. I wish you all the best. Thank you.